Good evening, everybody. My name is Michael Bryant. Me and Nicole Jefferson's working on this midterm project. The goal of the project is the professor gave us 1,000 images, and he wants us to match that one image to another image as the best results. So let's get to it. So me and Nicole broke it down into 3 goals. First is present all the pictures. So we do that by using the function, whatnot. I'll explain later on. We compare that one picture against the rest of the database that we create using data structure. And then the last one is we show the results best compared side by side. All right, there we go. So the first step, we select where the image is located off the C drive, which is we use an absolute to figure out where it is on the C drive to get a direct route to it. Then we display it, all the 1,000 pictures inside the display. The function image data structure creates a database that stores the 1,000 images. And then we use the next function to display all the images. So we set the value as 1,000 images, we set that value, and we display it. The second step, the function index images. So basically we create a whole dictionary of all the images together in a bag of features. Inside the bag of features is a function called the data search features. It is used to detect key features inside the images. So what it does in the bag of features is take 2,000 words of visual vocabulary to identify the pictures in the whole 1,000 picture group, and use it by using k-means clustering. Step 3, visual displays. We show the points of where the 2,000 points. The points that it visually can show it inside the picture. Figures results are side by side, and we show the best case of a cat search result inside our database. I'm going to go to the MATLAB program, and we're going to run it. Alright, cool. So, as the comment shows, we use the location words to verify the best search results. To re-rank the search results based on the geometric information, repeat this procedure for the top M search results. Specify the location of the images. Like I said, we use an absolute on line number 1 to our database, going directly to the path. It's an absolute. And then we named the pictures, the 1,000 pictures, and then that value is held inside 1,000 pictures. So the image data structures are held inside 1,000 pictures. And this is the figure of the 1,000 pictures being displayed. Alright, see the 1,000 pictures. In the meantime, like I said, it's going to take a while for it to load, because it has to take 2,000, make that vocabulary 2,000. So while it's making that vocabulary index of 2,000 to search the image of the cat, I'm going to go to my questions I have. Questions. What does IMShow X do? The next question. What happens if I change the max distance on line 41? On the MATLAB code. I'll point that out when I hit it on that 41 line code. And then next is which input in the function subset assigns the columns for the figures. I'm going to put on some elevator music as my code is still compiling. Let's go back to MATLAB. Right now it's compiling the bag of features from the detected search features. Like I mentioned before, I'm gonna put some cool background music as we go. It's my jam. It's gonna jam out to it. So this happens in 2 phases. The first phase, it initializes cluster centers. So it's making that vocabulary of 2,000 from the K cluster that we see here. Then it go ahead and makes those bag of features. I'm sorry, it's on 101 images, because I'm searching one, of course. So it extracted 261,415 images. It rebalances the number of features across all the image categories to include clustering. So basically, so it can identify a little quicker. So after it's done initializing cluster centers, it's going to do another iteration. After that iteration is done, I will show you the next set. Select and display the query images. Let's kind of jam out to my music till then. We're getting there. And my cool elevator music. And again, what is clustering is these 1,000 images that we see up here. I can zoom in for a little bit so you can see a little better. And right now it's processing, it's thinking. So the script is running, you know. Like I said, now it's clustering. Clustering is complete. Now the iteration of comparing the images is going to stop when it has a good sense of which words it can match the cat picture. Just bear with me here. In the meantime, as we wait, these are some of the workspace values I got back as we go through this journey. So there goes my database, that's where it's directed at. These points are the points where it found the same commonalities in the cat pictures. This is my eye iterations, which I'll explain as soon as we get to that line. Actually, I'll scroll down a little bit. So, once it's finished clustering, it's not done yet, but once it does finish, I made another variable called query directory, which again is going back to another set of pictures to figure out which one I'm looking for. So this one, this 108031, is a picture of a cat. Cat meaning by it's actually a tiger, but I call it a cat. So it's going to display a figure and it's going to show that the tiger. Once it is finished, we're almost there. Just bear with me. And right there, it just says how fast it's going, whatnot. It's the speed of the iterations. That's it. Now it's finished creating the bag of features, which again I said is off to detect surf features. So it's finished detecting the key points and features and the abstractions for my tiger. Right now it's compiling, it's thinking. Cool. Now it's 100%. We got my encoded 1001 images are done. Because I selected the image, that's why it's 1001. So it's finished creating my image index. So it finished making my library so I can search on top of that. Alright, so like I said, there goes my tiger. It's chilling in the water. Tiger. Next is going to retrieve the best matches based off of this bag of feature index. So it's going to find the best matches for the query images, extracting the visual words based off the surf feature I mentioned before. The image contains the visual words information for all the image. So it's going to search that query. Now this for loop is to generate a set of tentative matches based on the visual words. So basically that for loop is looking for the best picture match. I just want one that's going to match it. And now each visual word in the query can have multiple matches because it's doing a lot of quantization used to assign visual words, but it's looking for that one best match. So now I have my best match. I want to display it. I want to show the world. So this match, best results to other match. So you can follow the points. They don't align 100% right, because the bag of features is looking basically for the face of this lion and the chest of this lion. I mean tiger, not lion, tiger. It's looking for the chest and face of the tiger. It matches the chest and face of the tiger, and also some of the surround features match the image as well. So this is what we have here. We can continue a little extra bonus. We can remove the poor visual words assignments. Yeah. So we can remove the poor visuals, basically. So basically, where it's pointing at is where the poor choices are. That the back of features notice that isn't the best features to point out. But in this case, it works in our favor because it's pointing out the bodies and lines of the tiger. And that's it. And that's my project. Yeah, so I'm gonna go back to the set of questions I had before. My questions are: what does I am show X do? What happens if I change the max distance on line 41? Let me go back to line 41. Line 41. So this chooses the interval of line 40. Yeah, line 41. So this line 41, very important line right there. It's the distance that you want to choose for this estimate geometric transformation. So it's saying, hey, this point, how far is this pixel from this pixel? I chose 1.1 because that gave me the best attrition rate and gave me the best confidence of it. It says consider maximum distance or decreasing the desired confidence, but I'm confident of my results of what I got, so I'm going to ignore that warning. So yeah, my name is Michael Bryant. Me and Nicole Jefferson put this project together. Thank you for this Q&A, and this has been great. Have a great day. Don't forget to like my page. You gotta like it. You know it's nice. Thank you for watching. This is my midterm project. Have a nice night. And don't forget to like my page at the bottom. I think it's right there. It's the like. Don't forget to like. Or it's on that side. It's the like.